Hello, Bob Jackson here. We're going to start Module 2. Module 2 I call the Chemist Toolbox. In this module, what we're going to work with are measurements. Okay, measurements are extremely important, not only to chemistry, but in all kinds of things in life. I mean, if you're going to if you get into like furniture building, you're going to take a lot of measurements in order to cut the boards and get all the dimensions that you need in order to build that chair, build that table, or build that whatever. But you also use measurement in all kinds of construction projects. But you use measurements even in clothes. Clothes that you wear come in sizes. Those are measurements. If you're going to be a nurse, measurements are the quantities of the drugs or the IV bags or the things like that. Those are all in given quantities, which they had to be measured, and they're going to be set amounts. Okay, and you see this in so many areas, even cooking. You take measurements, otherwise some of the things you cook don't come out so good. Okay, but we're going to start with some very basic measurements that you're pretty familiar with, and then we will move on to measurements that we use specifically in chemistry. In doing this, we're going to talk units of measure. We're going to go from units of measure that you're probably most familiar with, like inches and feet and yards and pounds, to talking units that we use more commonly in chemistry that are in the metric system, like milliliters, liters, grams, milligrams, kilograms. But units are extremely important, and we will be doing all kinds of measurements and problems in chemistry that involve using units and the proper units at that. Okay, now then, one thing that we're going to get into in this module more than anything else are unit conversions. We're going to be working with problems, and you'll solve problems where you convert from one unit to another. Like I could have you convert pounds to grams, or convert inches to centimeters. Okay, they're pretty basic problems, but it's pretty important to do because in everyday life we have to do that a lot of times. In chemistry and in most all the science areas and technology areas, even with automobiles, you go working on things. About everything in the world today is a metric system. Okay, but we commonly use inches and feet and yards and pounds. So it's actually a pretty good thing to be able to do and know and be able to do whenever you need to do it as unit conversions. Okay, and in that, what you do is you learn to devise your own conversion factors using charts and tables that have the conversion factors on them. You are not going to have to memorize a bunch of conversion factors. Okay, we will work with scientific notation just a little bit. We're not going to spend a whole great deal of time on scientific notation. Scientific notation is just a means of simplifying numbers, okay, by writing them as powers of 10. So instead of this number that could be like 10,300,000 whatever, you're gonna write it like 1.0 times 10 to the sixth. Okay, or you could have a number rather than writing a number like 0.035567, you would go 3 point whatever times 10 to the minus fourth or minus fifth. Okay, it's actually a means of simplifying the numbers, but we're not going to do a whole unit of study on them or anything like that. I know some people can really get bottlenecked in working with scientific notation. We're not going to try to complicate things by having a whole lesson on scientific notation. It'll be actually in very few problems overall. Okay, and then the last part of this module will be working with density problems. Density is actually a very important physical property of matter and can be used to identify different forms of matter. You can tell what a metal is, identify a given metal particularly, if you find out its density. okay, but you can also determine all kinds of other factors about something when you know its density. Okay, so the last part of this unit, this module, we will work with density problems. You can also, with density problems, do conversions. Okay, because you can use the density, when you know the density of a substance, you can actually use its density as a conversion factor, okay, in a given problem. And I will be illustrating and showing you how to do that. Okay, so now then, measurement. Why is measurement so important? What are some tools we can use to measure with? What do you see there? Okay, weight is important to a lot of people. There's a lot of people, not me. I've never done this. My wife does, but get up every morning and get on a scale. Okay, getting her weight. That's a measurement, and that's important to a lot of people. And in today's world, for the more health conscious people, taking that measurement every day is extremely important to them. Okay, some people more than others, and it is a way of measuring their general health overall. Okay, and how well they're doing. Okay, what's that? Okay, it's a thermometer. Okay, when you got a sick kid at home and you want to get a quick read of their temperature, you can use that, and it's going to have a given unit on it. Okay, and most of us, I think, are most familiar with using degrees Fahrenheit. Okay, whereas you can switch, about all of them have where you can switch the unit on it to degrees Celsius, which we'd use more commonly in chemistry. Okay, what's that? Okay, a tape measure. Now, most of us don't use a tape measure like that, but a lot of people, like my wife, is a quilter. She loves to make quilts, and that is a tape measure that she uses in doing that, and measuring the cloth that she's going to cut out to put into the patterns of her quilts. Okay, but what units is that in? Okay, I believe that is in centimeters. Okay, but you're most common with a tape measure that measures in inches and feet. Okay, oh my God, what's that? A radar gun. What's been measured with it? Speed. What units is speed measured in? Miles per hour. And is that the only unit that speed can be measured in? No, it could be in kilometers an hour, right? You go to Canada, the Canadian Mounties up there probably have their guns set on kilometers per hour. Okay, and it'll get your speed. Kind of changes things up a bit when you travel in Canada or other countries. Okay, now then, this item, the vocational folks would know. It is a caliper, and this is where they can actually read in micrometers or micrometers. Most of them will call them micrometers, or they'll say they're going to mic something. Okay, right there, you take the measurement right there. You will roll those right there, pull on this arm, and you can pull that open, then squeeze it down on an item and measure the thickness of, like, a rod, okay, or a thickness of a metal can be measured with this, and you'll see the measurement right there. Okay, and that measurement will be in micrometers. Okay, so it's another tool that we use to measure with in society today. One that we use in chemistry is this guy right here. Okay, an electronic balance. We will be measuring in grams with these. Okay, but you can actually get them to measure in micrograms or kilograms. Okay, you can change the settings on these and measure in pounds or ounces, but we typically don't do that in chemistry. But it is a very important tool that we use to measure. Okay, anyone know what that is? That's pH meter. we can determine the pH of different solutions, different liquids. It's a very, very important measurement, not only in chemistry, but out there. You take some of the guys I know that are bass fishermen. They're really, really, really serious bass fishermen, tournament fishermen. They'll at times have they'll have temperature meters and pH meters and take a piece of water. There are favored pHs for bass, and you find the pH levels, particularly approaching down in the low 5 pHs. There's not going to be very many bass there. So it is a tool that is important. And we can also determine the quality of water in a lake or a pond or a stream somewhat by the pH of it. Okay, what's that? A multimeter, or some people call it a voltmeter. We can measure, typically you can measure an amperage, but most of us, I think, measure voltages. Okay, so if you want to test the battery and see whether the battery's still good or not for a car, you could use this and measure, see whether you're getting 12 volts out of that battery or not. Okay, but each and every one of these items on this page are tools that we use every day to take measurements. Okay, so why are measurements important? Because we need them for so many different things. Whether we're telling the quality of water, or we're getting the thickness of a metal, or how big around a rod is for a given machine, to measuring materials, or our own weight, or masses of items and substances we use in chemistry, to temperatures and even speeds. Okay, so there's all kinds of purposes to measuring, and it's important in a lot of different areas. Okay, so that's just some tools that we kind of use. Okay, now then, here's some units to measure. Now, it is expected pretty much that in chemistry you do memorize most of these, but most of you already know these units. Okay, I believe, because they're pretty familiar. I'd say the greatest majority by far know inches, feet, yards, and miles. Okay, and pretty familiar with them, and you've talked it on an everyday basis. Maybe a little less familiar, but most of us see anymore millimeters, centimeters, meters, and kilometers. Those are about the only units. There are a bunch more units in the metric system, but these are the ones we're going to concentrate on. We're going to keep it pretty simple. Millimeters, centimeters, meters, and kilometers. You do want to know the abbreviations for them. Okay. Okay, weight and mass. And most people are familiar with ounces, pounds, tons. Okay, those are what we'll use commonly every day. Whenever you go buy something, you buy something at the grocery store, and it's going to be measured in ounces or pounds. If you go buy some rock for your driveway, or have hire someone to haul some rock for your driveway, it's going to be measured in tons. But then we're going to move into the metric system, where we talk kilograms, grams, centigrams, and milligrams. Those are about the only metric units that we will use. Okay, most commonly. There might be a few others that we throw in there, but for the most part, kilograms, grams, centigrams, and milligrams. You do want to know the abbreviations for each of those. Volume. Most people are familiar with ounces, pints, quarts, gallons, and maybe barrels, like you talk barrels of oil. But your liquid, whether you're talking pop or tea or whatever, typically you're going to be in pints and quarts. You get a gallon of milk, okay, or a gallon of orange juice. Okay, people are familiar with that. What we're going to work more in here in terms of volume will be milliliters and liters. Okay, so you do want to become familiar with those, and also the units. Temperature. Temperature is pretty simple. Every day on an everyday basis, most of us are most familiar with Fahrenheit, and we can understand a temperature of 30 degrees Fahrenheit. Some of you feel it's cold, but likewise here in Indiana, you have a temperature in the 90s, you feel it's pretty hot. But you go to other countries, they're measuring Celsius, and it takes some thinking on whoever's part to determine whether it's a hot or cold temperature, like room temperature in a Celsius is around 25 degrees Celsius. Okay, so when you start working with Celsius temperatures, some people are unfamiliar with them, and you hear 25 degrees, you think it's cold. Well, it's not. Okay, 0 degrees Celsius would be what we know as 32 degrees Fahrenheit. Okay, when we get to the gas laws, we'll actually be working with Kelvin temperatures. We work with Kelvin temperatures in chemistry pretty much for the reason that there are no negative values on the Kelvin scale. You can't do a whole lot of math and it makes sense with the negative numbers. Okay, so the Kelvin scale is set to where there are no negative temperatures, whereas on the Celsius and Fahrenheit scales you can have negative temperatures. Okay, time, the unit we'll work with will be seconds. Okay, we won't be changing that up at all, and I think most of you are familiar with that. You can abbreviate SEC, a lot of people do, but it's pretty standard just to abbreviate seconds as a big S. Okay, we're going to be using these conversion charts. You will want to. I have one available for you when you get into the module. You do not have to absolutely memorize all this information. Okay, but we're going to be using this to do conversions, and the units are going to be put into charts like this. Okay, and this one. Okay, where we're going to convert from and between units. Okay, so now then, this is where we're going to get started. Now then, in my next video after this, and I'm actually physically going to be doing these problems with you, but for right now, I just want you to see if you can do these three problems right here. Okay, how many centimeters are in 6 feet is the first one. Now you're going to use the information to the left to do that math. Okay, where you're going to convert from 6 feet to centimeters. On the second question, it says how many grams are in 30 pounds. You're going to convert from 30 pounds to grams using this information over here on this side. Okay, so if you're doing this one, you're going to go pounds. You're going to look at your pounds information, and you're going to convert to grams by using this information here. Okay, on the first one, where you're going from feet to centimeters, you're going to be working with these numbers up here. And I want you to see where you can do this. And then on the third problem, you're going to go from 6 quarts to milliliters. Okay, how many milliliters are in 6 quarts? Okay, whereas you're going to use this information down here. There's your quarts. Okay, here's your milliliters. I want you to see whether you can do these conversions. Okay, now then, you're going to be able to look on here to see the answers. Okay, but I'd like for you to see whether you can do that on your own and get these answers that are right here. Okay? Now then, if you've taken the time to do these problems or kind of think them through, here's how we do them. Okay, in my next video that'll follow this one on SoftChalk, I will actually do some of these problems with you. Okay, that wraps it up for this session. Thank you.